talk about how to graph a log function, okay? Before we start graphing log functions, we need to understand some key concepts that relate exponential functions with log functions, okay? So the first thing, so we have this exponential function here, right? 2 to the x power. So we know that this is going to grow exponentially, right? And we also have the line right here, y equals x, all right? Now, since exponential functions and log functions are inverses of each other, right? Since they're inverses, we know that the graph of the log function will just be a reflection of the graph of the exponential function, right? So basically the graph of this log function, right, is just a reflection over the line y equals x of this exponential function, right? So since we know that to be true, some key ideas that we need to remember. One, the home point for the exponential function. Remember, for a basic exponential function, it would always cross through the point 0, 1. Well, since an exponential function and a log function are inverses, remember inverse functions, the x's and the y values, they switch. So you notice here, this log function, it crosses through the point, right, 1, 0. So you notice the x's and the y's, they switch, because that's what happens when two functions are inverses of each other, right? The x's and the y's switch, okay? So what you really need to remember is, log functions. So the basic log function, it's always going to cross through the point 1, 0, okay? The next thing, exponential functions, right? Remember exponential functions, they have a horizontal asymptote, right? Exponential functions have a horizontal asymptote. But log functions do not have horizontal asymptotes. They have vertical asymptotes, right? So in this case here, if you take a look at this log function, right? It has a vertical asymptote, right, at x equals 0. So remember, log functions have vertical asymptotes, right? So this function here, as right here, as this graph goes down, it gets really, really close to this vertical asymptote, but it will never cross it, okay? Functions can never cross vertical asymptotes, okay? They can cross horizontal or slant asymptotes sometimes, depending on the function, but functions will never cross a vertical asymptote, all right? So some really key things to remember, just remember for log functions, okay? Log functions, the home point is going to be at 1, 0, okay? Unless there's going to be some sort of, translations or transformations. Also, log functions have vertical asymptotes. They don't have horizontal asymptotes, they have vertical asymptotes. Oops. So if it's a vertical asymptote, remember the equation is going to be x equals something, right? Some number, okay? All right, so let's sketch this log function here, okay? All right, so for the first thing we're going to do is we're going to find the vertical asymptote, okay? And this value here tells you, right, where the vertical asymptote is, right? Now you just have to remember though, for a vertical asymptote, remember inside here, this is -4, that means we move to the right. So your vertical asymptote is going to be, right, at 4, 1, 2, 3, 4, +4 on the, going through the x-axis. Right, so just remember when you're finding the vertical asymptote for a log function, if this is a -4, you actually go to the opposite sign of this, right? So at actually +4 going through the x. So here's our vertical asymptote. And then now we go to the home point. So once again, there's no reflection to worry about or anything like that, and there's no number in front of this log. We'll do an example of those later. But right now, our home point, remember for a log function, the home point typically is always going to be at 1, 0. So right here, right? But these numbers are going to shift the graphs. So this -4 means we move the graph to the right 4, right? And this -3 means down 3. So from our home point, which is at 1, 0, right? We're going to move to the right 4, 1, 2, 3, 4, and then down 3, 1, 2, 3. So here's our home point. And then if the base of the log is a number bigger than 1, we know that the graph is going to have to look something like this. So we're just going to sketch this, right? And then this would be your log function, right? Pretty easy. Okay, so let's say we need to sketch log base 1/3 of x plus 2 minus 3. So the first thing, all right, I notice, all right, the base is 1/3. If the base is 1/3, right, and there's no reflection or anything like that, I know that my graph at the end, it should look something like this, okay, right? All right, so now let's find our vertical asymptote. So if this is a +2, right, that means we have to go to the opposite of that. We're going to go to -2 because we're eventually going to be shifting the graph to the left. So we're going to go to -2, and then we're going to have a vertical asymptote at x equals -2, right? Here's our vertical asymptote. Next thing, our home point. So our home point, remember, typically always starts at 1, 0 for a log function. But right here, this +2 means that we're going to move the graph to the left twice, and we're going to move down 3, right? So from 1, 0, we're going to move the graph to the left twice, 1, 2, down 3, 1, 2, 3, and then your home point is going to be right here, okay? Because there's no value in front here to worry about right now, right? So then we know, well, if the base is 1/3, what is this graph supposed to look like? It's supposed to have this shape right here. So it's gonna kind of go down like that, right? So it approaches the asymptote going this way. And over here, it goes away from the asymptote and keeps on increasing as x goes to infinity, all right? All right, so let's sketch this one over here. So first of all, I notice the base is 4, right? But I'm going to have a reflection, right? So we'll talk about that in a moment. So when the base is 4, typically I know the graph is going to be, then it's going to look something like this when the base is 4, right? But since I'm going to have a reflection, it's going to flip this graph, right? So instead of looking like this, it's actually going to look like this, right? So if you imagine flipping this graph, it would go down like that, right? So here's what my graph, actually, the shape of it should look like at the end, something like this, right? So first thing, let's find our vertical asymptote. So if this is a +5, I'm going to go to -5 on the x and sketch my vertical asymptote. So -5, 1, 2, 3, 4, 5. There we go. And then this +5 means we're going to move to the left 5. This +2 means we're going to go up 2. So from my home point, which for a log function is typically at 1, 0. All right, so from 1, 0, I'm going to move to the left 5. 1, 2, 3, 4, 5. And then up 2. Up 2. Right? And so this is where my home point will be. Now, we don't have a number here to worry about, so we can go ahead and just plot the home point. And what we do have is a reflection, right? And like I said, so if this minus was not here, and if this is a 4, the graph would look like this, right? It would look like this. But since there's a reflection, it's going to flip, so it's going to go down like this. So it's going to look something like this because of this minus sign right here. Okay? Take a look at this log function here. Now you notice this problem is a little bit different because it has this 3 in front right here. Okay? So let's see what that does to the problem. Right? So we start off, so the base is 5. Okay, so the base of the log is 5. There's no reflection. So I know the graph, when I sketch it at the very end, it should take the shape of, so if the base is 5, it's going to basically just look something like this, right? All right, so now let's find our vertical asymptote. So if this is a +2, the vertical asymptote is going to be at -2 on the x. So let's go to -2 on the x. So here's our vertical asymptote. And then our home point. Well, we know this +2 tells us that we're going to move the graph. It's going to shift 2 to the left, right? Left 2, and then down 1, right? Now our home point for a log graph, remember, it's gonna always be at 1, 0. Okay, so at 1, 0. And then what happens is, well, remember before when we had an exponential function, let's see, when we had a number in front of the base, right? This number would affect how you find the home point, right? So, but for a log graph, it actually makes things kind of easier because this number is not going to affect how we find the home point. And I'll kind of show you guys why. So right here, so if this number was not here, how would we find the new home point, its location? Well, remember, it's going to be at 1, 0 initially. And then we're moving to the left 2, right? 1, 2, right? And then down 1. And this is where you would put the home point, right? But since there's a 3 here, let's see if that changes things, right? So from our home point, we're moving to the left 2, so our x is -1. So we know x equals -1, right? So our home point is somewhere here at x equals -1. Now, if we plug in -1 into the problem, right, we're basically going to get this. 3 log base 5. So -1 plus 2, we're just going to get 1, right? -1. Well, if you think about it, if you just focus on this part right here, 5 to what power will give you 1? Well, it's going to be 0, okay? So we get 0 times 3, right, which is just going to be 0 minus 1, so we end up with -1, right? So if we actually plug in the x and do the work, you notice that, okay, when x is -1, right, the y is going to equal -1, right? Which is the same spot if we just basically, if we ignored all this work here, right? If we just started at 1, 0 and we move 2 to the left and down 1, 2 to the left, 1, 2, and down 1, that's where our home point is going to be, okay? So what this means is if you have a number in front of the log, right, it's not going to affect where your home point is going to be. So if it's a log function, you could just use this value and this value and move the home point, and that's where your home point will be at, okay? So it's not so with log functions, they're not like exponentials where if there's a number in front, you have to worry about, you know, how that affects the home point, okay? So basically our home point is going to be right here, right? So we move to the left twice, down 1. And then what's the sketch of the graph? Well, remember we talked about the shape of it. It's going to basically like something like this, right? Okay. Let's do another one so you guys see pretty much how this number does not affect in terms of where the home point is going to be. Okay. All right, so let's sketch this problem here. So you notice this problem, we have a number in front of the log. Okay. So what's the base? The base is 1/3. All right, so the base is 1/3. There's no reflection. So let's get a general idea of what our end graph is going to look like. So at the end, our graph, it's going to basically look something like this, right? If the base of the log is 1/3, the graph is going to look something like this. All right, so let's find the vertical asymptote first. So the vertical asymptote, if this is a -4, we know it will occur at x equals 4. So let's graph that. 1, 2, 3, 4. So we have a vertical asymptote at x equals +4. And then let's find our home point. So the home point for a log graph, remember it initially starts at 1, 0, always, right? And then, well, this -4 tells you you're going to move to the right 4 times. The +2 means up 2. So from 1, 0, we're going to move to the right 4 times. 1, 2, 3, 4, and then go up 2. 1, 2. Now remember we talked about how if it's a log function, if there's a number in front here, it's not going to affect how we find the home point, right? So log functions are not like exponentials where we need to worry about this number because it affects the home point. And let's show why that is the case again. Because So right here, our x value, 1, 2, 3, 4, 5. If x is 5, right? If x is equal to 5, if you plug in 5 here, you're basically end up with this. Y is equal to 4 times log base 1/3 of 5 minus 4, which is 1, plus 2. So this part right here, if you think about it, 1/3 to what power will give you 1? Well, the answer to that's going to be 0. Right? 1/3 to the 0 will give you 1. So this is 0. So 4 times 0 is 0 plus 2. So you know y is going to equal 2. So when we move, without doing all this work, if we just use these right here, the right 4 and the up 2, from 1, 0, if you go to the right 4 and up 2, you notice you're at the home point. Okay, and so you don't need to do all this work to verify what the y value is going to be for your home point when you have a number in front here. So that's unnecessary when it's a log function. And then let's sketch it. So we know the sketch of this. It's going to look like this right here. So it's going to go down. And over here, it just approaches the vertical asymptote. Okay?